Hello everyone, welcome back to Scalers YouTube channel. Today we're going to look into the GCP tutorial and the module 4 of it. In module 4 we're going to look into Cloud SQL and other database services. And before we move on and understand about that, please make sure to subscribe to Scalers YouTube channel so that you don't miss our upcoming videos and also the upcoming tutorials in this particular series. Also, if you want to learn from industry experts, especially about technologies and frameworks, we are conducting free masterclasses and the link is in the description. Now, let me quickly summarize what will be taken in this particular session and then let's get started. To start with, I'll be discussing what are cloud databases, how they are different from a regular on-premise or a local database. After that, I will basically talk about Cloud SQL itself and also other database services that GCP provide. And once that is completed, finally I'll show you the demo of Cloud SQL itself. Hopefully you have created the account which I was teaching in the first part of this particular series. So make sure you take this particular demo along with me using your account. So now that's basically it. Let's get started with the session. So GCP database services. Let's get started and understand what exactly is a database itself. So a database is a collection of organized and structured data that can be easily accessed. Again, it doesn't exactly have to be structured all the time. The relational databases have structured data stored in them. And for example, NoSQL databases like MongoDB, they have different formats of data. Like you can store it in a document format, you can store it in JSON, that is key value pairs, and there are so many other types. But the basic understanding of a database is that it's an organized, structured data set which can be easily accessed. We can easily retrieve information from there. We can easily add information over there, and we can connect it to multiple applications. We can do all sorts of actions with it, basically, right? So from this PPT itself, you can see that it's a collection of organized and structured data that can be easily accessed, managed, and updated, right? So it is designed to store information in a way that enables efficient retrieval and manipulation of the data for various purposes, such as storing customer information, managing inventory, or tracking financial transactions. So these are just examples. For example, any website or any application you use has to have a database. If you use a food delivery application and if you're seeing a bunch of restaurants on it and you are seeing various menu items in a particular restaurant, all of that information is stored in a database, and whenever you open the application, that's when they retrieve that information and show on your feed. It's not always stored in that application, because if all that data, all that images are stored in your application itself, then all that data has to be stored in your local storage of your phone, and that would not be efficient. That is not uh, best practice as well, because when you store all the data on your local phone, that will take away the basically the benefit of having it stored in one particular place, and that will also reduce the cost for the company, because if you download one particular application and that's like 5 GB, what's the use of that? So that's just a very simple example I'm giving you. You can go ahead with a database, because for example, if the food delivery application would be using a database, all that information would be retrieved from that database whenever you open the application. If you're booking a flight, that flight data is stored in a real-time database somewhere. Similarly, if you are booking a movie ticket or if you are using Google Maps, even then there is some information which is stored in the database. For example, in Google Maps itself, if you click on a particular location and you create a title for that location, let's say you have a new store and you want to set that up on Google Maps. So you create that particular store's information on Google Maps, and that information is stored in Google's databases. Even though it's on the map and you're able to click and it immediately shows up the information, as you click that, Google is able to collect that data from the database itself and is able to load in that application. So this is some of the examples I just wanted to give you, because without a database, you would never have any kind of application which exists right now. Databases can be simple or complex, ranging from a single table to multiple tables with relationships between them, and can be managed using database management systems such as MySQL, PostgreSQL, Microsoft SQL Server. There are so many more database management systems. These are just some of the popular ones. There is also Oracle DB, there is IBM's DB2. Yeah, so we can just name so many database management systems. And again, talking about a single table and a multiple table with relationship between them. A single table is just one single tabular table in a database that has no relationship or connections whatsoever. It just is one single table with information in it. That's basically like an Excel sheet, just with one single sheet. But when you're talking about multiple tables with relationship between them, let's take, for example, a college, right? Or let's take a library. There is an inventory of books. So now all of these books will have an author, and it'll have a price. It'll have a particular genre. There are crime books, there are literature, there is art, there are so many other varieties of books, right? So now one author can have 10 books. So how will you show that in a database? For that, you'll have to have multiple tables. For example, there would be a table of books. In that table, let's say there are 5 books of one author and there are 2 more books of another author. Now, there will be another table which is for just authors, and in that table, it will be mentioned this author's name, and there will be the number of books they have published. So now you can correlate these two tables with each other, and you can retrieve information even more effectively. That's basically multiple tables. So if you want to learn more about databases and also you want to learn SQL, that is structured query language, check out a video which is already available in our YouTube channel, which is made by Shashank Mishra. It's in the top right. You can go ahead and check it out right now. We'll link it. If not, you can just go to our YouTube channel and just search for DBMS courses and SQL courses. There are 2 individual courses. You can go ahead and learn from that. And if you already know about databases, you want to learn more about cloud databases, please continue. Now, what is a cloud database? Cloud databases are, again, they are exactly same as databases. The only difference is, in this case, the databases are hosted on the cloud. Cloud is not a logical thing, it's a physical thing which exists somewhere. It's basically you are renting a particular infrastructure. For example, this laptop can be used as a server, but this is my personal computer. Now, if I rent this to someone and let's say they are able to access my laptop, then we could consider it as a cloud. They are using my laptop as a cloud infrastructure. Similarly, Google have their own data centers. They have invested heavily because they are a $1 trillion company. They have a lot of money to invest in data centers. So they have a global infrastructure of data centers, and you can choose in which data center. For example, if you're in India, you can choose the Mumbai region or the Delhi region. If you're in US, there are so many other regions. There is North Virginia, California. There are so many other regions you can select from. So now these regions are basically where this particular physical data center is located, and in that data center there are physical hardwares. There are rows and rows and basically of servers, which consists of storage, computing power, and more. Over there, you can create your own database, and they would give you the information and the details of that particular database, and you are able to access a database that is running in the US from India using your personal computer. You don't need any high spec computer. You just need the most basic computer, just with an internet connection. That's more than enough, because there is no GPU usage or CPU usage in your computer itself. It is all done in Google's data center. So that's how a cloud database works. You don't have to set up anything. You don't have to install any software. You just need to know how to create a cloud database. That's it. You can create a cloud database in a matter of a minute. That's all it takes. But to understand what exactly is the process behind that, how to utilize that, will take a little bit more time. Now, again, coming back to cloud databases, they are hosted on cloud computing platforms. In this case, they are hosted on the Google Cloud Platform. They allow users to store and access their data over the internet from anywhere in the world, and typically offer features such as scalability, flexibility, and ease of use. Again, if I have the database running on my computer, on my laptop, I can't access it from anywhere because it is only running over here. And until and unless I set up my laptop as a public server where anybody could access from anywhere, then there is no use. But if the database is running on the cloud, it doesn't have to be this particular PC. I can log in into my Google Cloud Platform account from any computer I want, from anywhere in the world I want, and access the exact same database from anywhere. That's one of the main benefits of a cloud database or any cloud computing tool, right? It offers scalability, flexibility, and ease of use. Scalability is, let's say right now you just want a database with 20 gigabytes of storage, and your application gets popular overnight, and now you need 1000 gigabytes of storage, and you can scale that in an instant. Flexibility, you can delete it or uh, basically create more whenever you want. You can migrate from a different schema of a database to another one. For example, from a MySQL database, if you want to migrate it into a Postgres cloud database, you can do that. There is a migration tool within Cloud SQL itself. Yeah, so these are some of the benefits, or let's say the basic features they provide, because without these there would be no use of a cloud database. Next, cloud databases can be used for a variety of purposes, including storing business data, managing website content, and running software applications. Yeah, these are the most obvious examples. Uh, that is, when you have an application, you will have business data, you can store it over there. You can manage your website's content by keeping a database for that, and also software applications. Any kind of application would need a database, right? So this is basically what a cloud database is. Now let's go ahead a little bit more and further dive deeper into the GCP database services and look at all the different offerings they provide. There are still more. For example, if you look at the screen, there is Cloud SQL, there is Cloud Spanner, there is Bigtable, Firestore, Memory Store, and also storage for Firebase. So now these are 6 different database services that GCP provides. There are still more. If you want to learn more about other database services, you can go ahead and check GCP's website itself. But the most popular and common ones are these. First, Cloud SQL. Let me not talk about Cloud SQL right now because anyway, the session is about Cloud SQL itself. I'll be talking more about it. I'll start with Cloud Spanner. It's an horizontally scalable, globally distributed relational database with strong consistency. Horizontally scalable in the sense you scale it in terms of numbers. That is, let's say you have a database right now and you want to improve your website's functionality or your website's availability, then you can create another database. And when there are more customers, then your user base grows even further, then you can create another one. You can keep on adding more databases, and that creates a complete network of databases that is keeping your website running. And also, horizontally scalable doesn't mean you can only scale out, you can also scale down. That is, let's say to in the from 9 a.m. to 9 p.m., let's say that's your peak hours in the daytime. So in that particular instances, like for those 12 hours, you can have maybe 50 database instances running. And after 9 p.m., let's say your user base goes down. For example, if it's a food delivery application, people might start ordering from around 6:30, and the peak will be till maybe 10:30. Even that, after that you get orders, but it won't be as much as this particular period of time. So for that period of time where there is a lot of traffic to your website, you can have a lot of databases running. And then when in the night time, after let's say 12 to 6, in that particular 6 hours, you wouldn't get a lot of orders, so you can decrease the number of database servers that are running to basically it will decrease the operations cost. It will decrease it won't decrease your application's availability or functionality or the performance in any way, because at the peak, let's say there are 10,000 customers ordering food at the same time concurrently, but at 2 a.m., there would be maybe 100 people ordering from your website. So that is basically a drastic reduction of users. And for that, you don't need 50 database servers running. You might just need 10, right? Yeah, so this is where Cloud Spanner comes into place. You can use this for scaling up and scaling down your database instances. And then Cloud Bigtable, a fully managed NoSQL wide column database for large analytical and operational workloads. Okay, so NoSQL databases again are mostly used for analytical workloads, or you can call it OLAP, online analytical processing. So what exactly are analytical and operational workloads? To put it simply, for example, there would be usually there are 2 different types of workloads. One is a transactional workload and one is an analytical workload. Transactional workloads are the actual processes. That is, for example, if you're transferring money or getting money from someone, a transaction would be so for example, in your passbook there would be a transaction. So that particular thing is noted down in a relational database. But for example, there is another part. You get your financial analysis. So for that, For that kind of purposes, to analyze your income, to analyze your finance, there is another set of databases for that. So in that case, it will be in a NoSQL database, and it's a wide column database, and it is mainly used for analytical purposes. So what exactly is the main difference between, let's say, a database which is mainly for analytical purposes and a database which is mainly for transactional? One thing is that in a transactional database, that is Cloud SQL, or a relational database, in this case, everything is structured. But in analytical database, it doesn't have to be exactly structured. It can have it can basically have a JSON-like or a tree-like structure. Right? In this case, it's a wide column database. And then there is Cloud Firestore, a flexible, scalable NoSQL document database. The previous one is a wide column database mainly used for analytical and operational workloads. Firestore is a NoSQL document database for web and mobile applications. Again, document database is another type of NoSQL database. Right. And then the fifth one is Cloud Memory Store. Memory Store is an in-memory database. For example, you would have heard the term caching or a cache. Basically, caching is to decrease the load on the servers. There is a caching server in between your local PC, or for example, let's say you are the user, you are trying to retrieve some information. So now that particular information request will first go to the caching server. The caching server will check if it has the information, if it is frequently requested by the user itself. If it is frequently requested, you will get that information immediately back because it's in the caching server and it doesn't have to load anything. If it is not there, then it will go to the server, fetch the information and send it back to you. So that's where Cloud Memory Store comes into place. If you have an application where lots of users will basically use a similar feature or the same feature again and again, then you can set up an in-memory data store. For Redis, it's mainly used for caching and session management. Session management is basically when you get into a website and let's say you have added some products, even though you're not logged in, that products will still stay in cart until you finish and you close that particular website. Or even if you open the website again and you've not closed the browser, those products will still be in the cart because of session management. They would have stored that data, and as soon as you open your website, that data would be taken back by the website and it will be added over there. So that's where Cloud Memory Store comes into place. And then finally, a NoSQL document database for mobile and web applications with real-time updates and offline capabilities. Firebase was a separate database. Now they've included it with Google Cloud itself. And its storage for Firebase, it's also a document database. It's also NoSQL. You can use it for mobile applications, web applications. I've used it for mobile applications. It has really good real-time features and also offline capabilities, right? So these are different database services that GCP provides. So now the next topic we want to start off with is what is Cloud SQL? So now Cloud SQL is a SQL database. It's a relational database that uses structured query language to retrieve information. And it is stored on the Google Cloud. That's why it's called Cloud SQL itself. So now it's again a fully managed relational database service provided by GCP, fully managed in the sense you can create the database using GCP itself. Once you create it, you can create databases within that particular database instance. You can set up anything which you do in a normal database in your local system or in your on-premises data center. Every single thing can be done on Cloud SQL. And they also provide other features. They provide query analysis. That is, you can check where the queries are coming from. For example, if your website is global, that anybody from anywhere can use your website, you can have a query analysis where you can see where the query came from. For example, today the 100 queries came in, 20 were from US, 30 were from India, 50 were from different parts of Europe. So you can basically check it like this. And then there are other support, there is logging features, there are monitoring features, and yeah, so these are the things which you'll have to manually set up in a data center if you have your own physical data center. In that case, you'll have to hire personnel for monitoring, you'll have to hire personnel for setting up, maintaining and everything. But in this case, with cloud, they do that. They hire maintenance people and maintain the databases and the physical hardware for you. You'll just have to make sure you basically pay the subscription fee, which is getting generated every month. Now, it supports MySQL, PostgreSQL, and SQL Server. The three database services it supports right now are MySQL, PostgreSQL, and SQL Server. You can't have other database services or the other database servers running on it. If you have a different database, for example, let's say you have a DB2 database in your local system and you want to migrate into Cloud SQL. In that case, there is an option to migrate from a different database into a database which it uses. For example, you can't have DB2 schema itself running on Cloud SQL, but you can migrate DB2 into a MySQL database or a PostgreSQL database or a SQL Server database, right? You can do that, but you can't use DB2 or an Oracle DB on top of Cloud SQL. Also, it simplifies migrating from on-premises database systems to Cloud SQL. So this is what I was talking about right now. It also offers features such as replication, automatic failover, and integration with other GCP services, making it a reliable and efficient option for running relational databases in the cloud. To put it very simply, replication in the sense you can exactly replicate the same database in real time. That is, once you replicate the database, it will have a complete copy of the same database, and whenever you upload or insert new values to the main database, it will get replicated in real time to the other database as well. But again, it's not always in real time. We can also set up an asynchronous sync up. That is, once the database gets updated, it'll take some time to update over there. If you set up a synchronous one because it's a read replica, then in that case you will have to so basically whenever you upload data or update the database, it will get updated in real time itself. Now, automatic failover is another concept which again I will tell you more about. Don't worry about it right now. And integration with other GCP services, that is, you can connect your Cloud SQL with the Google Compute Engine, which we already learned about. For example, you can have a Google storage bucket account where you have a lot of objects. Let's say there are images you want to retrieve. Those image links can be stored in the Cloud SQL database, and that can be retrieved by the GCP with basically in GCE with your code. Now, these are the different types of features it provides. It's basically what you can do normally, but with a little bit more added benefit that you can do it from anywhere, and with basically benefits and features like replication, failover. You don't have to worry about your database going down or having to face a major downtime for your application. Now, let's look at the key terminologies which we will be discussing throughout this particular session, and also which are really important for especially databases and especially Cloud SQL. Number one is a database instance. So now, a database instance is a set of software and files that operate the databases, MySQL, PostgreSQL, or SQL Server. So now, the database instance itself is one part. For example, you create one database using Cloud SQL. That is a database instance, one single instance, right? That one single instance can have only one database software running on it. It can be MySQL or PostgreSQL, or it can be SQL Server, right? It can't be multiple different database systems running on one single database instance. So database instance is just one single entity, or for example, in GCE, that is Google Compute Engine, over there we created one virtual machine, and one virtual machine is basically one instance, right? Same way in this case, one database instance is just one single entity of the database you've created. Next, public IP and private IP. So to put it simply, we already learned a little bit about this while we were learning the GCE module. So now when you create your database, you will get a public IP if you set up public access for your database, and a private IP. A public IP is basically when, for example, your database needs to be accessed by a user base, which is basically across the globe, or a public user base. In that case, you would need a public IP. Without a public IP, nobody else can access your database directly. Also, if you want to connect your database from outside the network, for example, let's say you are not within your company's network or not within the network which you created in GCP, then you can't access the database you created. So for that, you will need a public IP. Next, a private IP is basically, again, you shouldn't give away your public IP to users. That's not a best practice. but for practice by yourself to simulate the experience of a user or simulate the experience of a regular person trying to set up uh, a database. In that case, public IP would help you. But when it's an application, then you should only use the private IP. So how does that work? For example, your website is hosted on a front-facing server. It's a front-facing server because users are able to see that. And when users are able to see that, then in that case, that is hosted on a public server. Now that public server will be connected to another private server where all the business logic and other information is stored over there. So in this case, this private server, right, would not directly be accessible to the public user base, because this data should not be revealed to them. Only the website's main information, that is the website itself, can be shared with them, which you can see on the website. For example, if you open Amazon's website, in that case, you just see the website, you see the products available, but you don't know how exactly the products are there, how exactly buying a product works on Amazon. You don't know that because that code is stored in a private server. So now there is another layer, which is the database layer, which is even behind that private server. So now the database can be only accessed by this private server, not even the public server, because if the public server is able to access the database, hackers or other people with malicious intent can try to get the data stored in the database. But if there's public server, this public server will access the private server. So now the private server and the database instances will be within the virtual private cloud, which is basically a cloud network which is isolated from the public network. So now within this, only this private server can access and retrieve data from that database, and then it will give that information back to the public server, which will show it on the website to you. So if you click on the website and then you click on a particular product, that information is not readily available over there. That information is taken from the database and then given to you. So now this is what happens in the back. The public server, which is the website itself, sends a request to the private server, and the private server has the business logic which helps it to retrieve the data from the database, and then the information is passed on to the website itself. Right, so this is basically it. So that's why you would need a public and a private IP address. Within the network, you will need a private IP. For a front-facing, internet-facing website, you would need a public IP. Next, high availability. High availability is basically increasing the reliability on your database instances. That is, your database instances will always be running. Even though your database instances fail, there is a standby or a backup for it. That's basically high availability. Now, failover. A failover is when Cloud SQL switches serving from the original primary instance to this standby instance. So now failover is, for example, let's say you have your primary instance running in one particular location, and there is a major power outage in that location, and the entire physical data center goes down. So in that case, your database will also go down. So when your database goes down, what happens is your application doesn't have a database, so that your application will also go down, and that will cause a major problem for users and also the company itself. But instead, you can set up for an automatic failover. An automatic failover is basically another standby instance is readily available whenever the primary database goes down or is not working. In that case, the standby instance will become the acting primary instance until the actual primary instance comes back online. That's basically what failover is. Next, a clone. When you clone a Cloud SQL instance, you create a new instance. It's not a replica, or it's not the same instance, but it's a new, completely different instance with completely different credentials, and it's a new copy, and it's basically a completely independent database. After you clone, the data which was in the database will be copied, but the data which you're updating to one database will not be copied over or transferred to the other database, because they are two individual databases. But there is something else called replication or a read replica. So in this case, it's pretty much like a clone, but in this case, it's not a new instance. It's the addition, or it's basically the same instance but a new copy, which has the exact same schema, which has the exact same data, and whenever you update data to the primary database, it will get transferred and replicated to the other database which you have just replicated. So that's basically read replica. So a read replica is also not used for writing, that you can get it from the name itself. You can't write data or update data in the read replica. Read replicas are mainly for retrieving information. For example, you don't have to have 10 databases and keep them all as both read and write. But you can have two databases where you can just write data into it, and you can then have 8 databases from which you will just need to read information from, that is retrieve information. Because most applications are let's say for retrieving information for the users, right? And 80% of the time or 90% of the time information is retrieved. That is, when you open any website, you get the information, you basically try to retrieve products information, then try to buy it. For all of this, you are just reading, you're not in writing, or you're not giving any data. For example, writing is mostly a very rare process. For example, if you're buying a product, you write your address, your card details, your personal information all once, then it gets all stored in the website's database itself. So now after that, you're not writing anything to the database. After that, it's all reading. You're reading the product's information, you're clicking on buy, and then you go to the payment portal and pay it. So now for this case, you would not need, you basically don't need a writing option itself. You just need to retrieve information and then buy the product. For that, you can go ahead with a read replica. So these are some of the terminologies in Cloud SQL. Let's look at the overview of a Cloud SQL instance. Now, once you create a Cloud SQL instance, or when you're trying to create a Cloud SQL instance, these are the different aspects. These are the different things which are basically put together to make one single Cloud SQL instance. Now, a Cloud SQL instance is powered by Google Compute Engine itself. That is a virtual machine. So now it's basically a virtual machine which is running, and the virtual machine will have the SQL databases. For example, if you are running a MySQL database, the MySQL software files will be already installed in a virtual machine, and that's basically used as a database server. It's not anything different from a regular virtual machine which you create. For example, when you create a virtual machine, there is nothing in that. You will have to install all the software you need. But when you create a Cloud SQL instance, in this case, what happens is it automatically creates a server for you. And once it creates a server, it installs all the database software in it for you. But you wouldn't know, because it's all happening in the cloud. It's all happening in Google's data center. They just show the loading function on the website, and then eventually you get all the details for your database. So now within this particular instance, there are so many different aspects which is keeping it working. Now, looking at this particular diagram over here, you can see this is the Cloud SQL instance. The Cloud SQL instance has inside that there is a virtual machine running, and within the original virtual machine there is an operating system running, and in the operating system it's just Linux. Windows is not used in these cases. It's always Linux, because 90% of cloud servers use Linux. Now, within this virtual machine, a Linux operating system is running. Within that operating system, and again, if you're using SQL Server, then it's my Windows, because SQL Server is theirs, right? But in this case, it is a Linux, because I'm going to use MySQL or Postgres. So now, within the operating system, a database server is running. It can be MySQL, or it can be PostgreSQL, or third one is SQL Server. So within that, one of these is running according to what you select. And then there are other features also running. There is a logging agent running, there is a monitoring agent running, and there are other services running along with it. For example, logging agent will keep logs of all the events happening, the incoming queries, if there is an error, if there is a fault, if one particular table is not able to update, or there is a connection issue between two different tables. All of these logs will be kept by the logging agent. The monitoring agent again monitors the database. It checks how much data is coming in, how much has been deleted. So basically what any monitoring agent does. And then there's a persistent disk. The data, whatever gets stored or inserted, will be stored in the persistent disk which is attached to the virtual machine. We already learned what a persistent disk in the last session. We already learned about virtual machine in the previous one. So the virtual machine will always have a persistent disk attached to it, and that persistent disk is where all of these data is stored. But the data is structured in the database server, which is running in the virtual machine. Now, the virtual machine also has a high availability standby database instance, standby virtual machine running. So, if this particular virtual machine goes down, the standby virtual machine will automatically come online and will act as the primary database. And the virtual machine inside is connected to a static IP address. Why exactly a static IP address? Because if it is a regular IP which is dynamic, and every time you restart, the IP address will change. If the IP address changes every single time, then you'll have to make that change in the code again and again, right? But if it is a static IP address, throughout the life cycle of this particular database instance, the IP address will persist. That basically is the same IP address will be available till you delete this particular SQL instance. And without a static IP, it doesn't make sense to have a cloud SQL instance, because if the IP address keeps changing for practice, maybe, but it automatically comes with a static IP address. And then you connect it to an application that's outside of the Cloud SQL instance. So this is what is available within a Cloud SQL instance. I hope this is clear. If you have any doubts, put it in the comment section. We'll have a discussion over there. Right. Now, looking at the features, and then after the features, we'll start off with the actual demo itself. Now, automatic backup, replication, and failover to ensure high availability and data protection. This we've already discussed. Scalability to handle growing workloads with ease. Again, you can scale down, you can scale out, you can increase the number of database instances, you can decrease it, you can increase the storage alone, and you can decrease the storage according to your requirements. This will basically decrease the operation costs, because if you need more storage, you would increase it, but when you don't need it, you would decrease, or you decrease the number of servers. That will directly reflect in your cost, right? And then integration with GCP services such as Compute Engine, App Engine, and Kubernetes Engine. This we already talked. Integration with other GCP services. Flexible pricing based on usage, with options for on-demand permanent billing or package pricing for sustained usage. So there is this option called pay as you go, which is on-demand permanent billing. That, for example, if you run the database for 40 minutes, you'll only have to pay for those 40 minutes of usage. For each minute, there will be an amount, and that will get calculated over time. And for every single minute, you pay that particular amount. That is flexible pricing. Or if you are an organization and you want 10 database servers to be always available for a year, then you can go ahead and buy the package. That is the 1 year package. That will give you a reduced cost by 40 or 30%. That depends on the sales team which you work with when your organization talks to the GCP sales team. But again, flexible pricing is the most used by people who practice, or people who are trying to build their own products using cloud and GCP. Right. Flexible pricing, and finally security features such as encryption of data at rest and in transit, and access controls to protect against unauthorized access. So when the data is at rest in the persistent disk, there is encryption. So if data gets lost or stolen from the persistent disk itself, it will be not usable because it's encrypted. Even in transit, that is when the data is being retrieved, even then it is encrypted. Once it comes to the source of retrieval, then it basically gets decrypted and the information is shown to you. That's basically it. So these are the major features of Cloud SQL. Now in the next session, we'll start off with the Cloud SQL demo. I'll just tell you what we'll be doing in the demo before moving on. First, we'll start off with creating a database instance itself. I'll show you all the aspects of creating a database instance. You can create one along with me. After that, I'll show you how to connect to this database instance using the Cloud Shell, the Google Cloud Shell, and I'll be showing you also the basic SQL commands. I'll be creating a database in it. I'll be creating a table in it. I will insert some values. Then I will just run some basic SQL commands to show you it is basically the same as a database running on your local system, right? So this is it. Now let's get started with the demo. So now let's start by creating a database instance. So I've already opened the Cloud SQL console on the website. So basically you can log in right now and then search for Cloud SQL, or just click on this side. You will get all the options over here, and then click on SQL, and then it will open the Cloud SQL console. So once it opens, immediately the first option itself is create an instance, and that's what we're going to do. And then they have just given more information about it over here. If you want to watch this, you can watch this. It's basically what I've been explaining. It's a quick summary of all these features over here. Okay, so now create an instance and migrate data. There are two options. First one creates you a complete database which does not have any data in it. It's a fresh database. Migrate data asks you for the source from where you want to migrate. So currently I've not enabled it because I've not used the migration service, and it's a little bit uh, more complex than just creating a database and getting started with GCP, right? So now you can go ahead with this if you want migration. So once you do this, it'll have an option. It'll ask for the source and the destination. Source would be the database from where you want to migrate the data to. Destination would be the Cloud SQL database, and then the data from the source database will get copied into the destination. Yeah, so that's basically what migration of the data is. Right. Now let's start off with the actual demo, that is creating a Cloud SQL instance. Click on Cloud SQL. Then you have the database engine options. There are three. There is MySQL, there's PostgreSQL, and there is SQL Server. These are the three different options. I'm going to go with MySQL because that's the one I'm accustomed to. And then there is Postgres, there is SQL Server. According to what your needs are, click on. Or if you want to practice, just want to see how to create a database and how to run queries on the cloud, then just follow with me. I'm choosing MySQL. Now, instance ID is the name of the Cloud SQL instance which I'm going to create right now. So I'm going to just name it as instance 1 tutorial so that it's easier to navigate. Password, we can generate a password or you can create a basic password, but it should not be really basic. For example, if you're going for a production database, obviously you'll have to generate a very strong password. It can't be a weak one. But right now, as we are practicing, I'm just going to go with a very weak one, that is admin123. Never use this particular password because obviously passwords like these are very easy to crack, and this is one of the most common passwords that people use in a database, right? Admin or admin123, right? Or you can choose the MySQL database version. I'm just going to go with the latest option they provide, that is MySQL 8.0. And then over here, there are two options and there are more configuration details. You can choose production or development. I'm going to go with development because production is, you can see here, optimized for most critical workloads, highly available, performant, and durable. This is a little bit more expensive. But again, even though we are in the free tier limit, we would have credits. You can go ahead with production if you want to test it out. But again, I'm just going to go with the development configuration because over here you can see production mode is highly available. I'm not going to run a powerful application which has a lot of workload. I'm just going to create a database, work with it, and then delete it. So I'm going to go with the development one. It's a single zone, two virtual CPUs, 8 gigabytes of memory, 100 GB of storage, automatic storage increases. That is, for example, let's say 100 GB is done and there is 10 more GB of data incoming. In that case, what happens is it automatically increases to 110 or 120 GB, and that data is also added. If the limit is 100 GB, it's not like only 100 GB can be uploaded. It automatically increases. That it scales itself. Automated backups, it's enabled. I will disable it because again, we don't need backups. If it is a mission critical database where your data should always be backed up, then always have automated backups. Point in time recovery is when, let's say, up till 4:30 you had a set of data and right now it's like 4:45 and your data is lost. So you want to retrieve information which was there up till the 4:30 point. So you can exactly go and retrieve information from that particular timestamp. That is point in time recovery. Maintenance order any later. So again, this is fine. Now the next option is choose region and zonal availability. So as this is a single zone, if I want, I can choose multiple zones, even for my development uh, configuration, but I'm just going to go with single zone. Over here, you have a lot of options. You can see these are the ones which are closer to me, Mumbai and Delhi, but I'm just going to go with low CO2 emission data center, because anyway, I'm not going to use it for there won't be any latency issue for me, because if you're having an application which is meant for India, in that case you can choose the India data center, the latency will decrease. But again, as we are just practicing, just choose the default one or choose another one which has low CO2 emissions. Yeah, so this is done. And then if you want, you can specify a particular zone, or it will just create basically take a random zone. It will take A, B, C or F automatically. You don't have to specify any. It will automatically take one, so don't worry about that. Next is customize your instance. Now, these are basically the information which was shown here, right? Now, if you want to customize it rather than keep it by default, you can customize all that information over here. If you want a high memory database, or if you just want a standard or a lightweight, which basically you can see it's just one vCPU and 3.75 gigabytes, and custom is basically two vCPUs and 3.75 gigabytes of memory. I'm just going to go with this and leave it right there and go to custom. Yeah, let it be 3.75. That's the least, and that's more than enough for practice. Storage, SSD is recommended, because obviously SSD is faster. Solid state drives are faster than hard disks, so go with SSDs. But if HDDs are basically cheaper, for example, if you want to store backup data or archival data, then you can store it in HDD. If you're going to store data that you want to retrieve every now and then, if it's an application where data will be retrieved every single minute, every single second, in that case, SSD is the best option to go for. It's more expensive than HDD, but again, data throughput is higher, it has a higher QPS, it has lower latency. That is, to retrieve information, it doesn't take a lot of time, but HDD does. And you would have seen in the laptops itself, when you add an SSD, it gets faster because SSDs are faster than regular hard drives. It can write and read faster. Now, storage capacity, you can keep it at 10 GB, 20 GB, 100 GB. Depends on what you want to keep. So again, I'm just going to keep it 100 GB. It won't affect me a lot because I'm not going to store a lot of data anyway. Even if it's 10 GB, I'm not going to store a lot of data in it. And then enable automatic storage increases. You can disable this if you don't need. It automatically increases if the storage you need goes more than 100 GB. It automatically increases the limit by itself. Encryption options are available. You can just go with Google managed encryption key, or if you have your own encryption key which you have created, you can also use that. Connections, public IP is enabled over here. If you also want a private IP, you can select it. I want both IP addresses. I just wanted to show you guys. But right now, I don't have a VPC which I've created, because that we'll be looking at in the next module. But right now, I'm just going to use the default one. Now, private services access connection. Your default network requires a private services access connection. This connection enables your services to communicate exclusively by internal IP address. So now, if you set this up, what happens is a private IP also will be given to your database. Now, the private IP can be used to access your database directly without an internet connection within the network itself. Because within the network, they have basically it's kind of a LAN. If I connect this to another laptop using a LAN cable, I can get information from that. I can share data from this. So it's basically like that. They are connected within a private network. So with a private IP, a server within that VPC can access the other database. That's basically it. So you can go, I can set up this connection and go for it. For now, I'm just gonna disable this. I just need a public IP address. It can be accessed from an external internet accessible source that is internet facing. I can access this with my laptop. You can, if you have this details, you will also be able to access the database. Next comes data protection. You can see automated backups, 1:30 p.m. to 5:30 p.m. I'm just gonna. You can change any time slot you want over here. It'll only backup in that particular time zone. Enable point in time recovery. It can be there over here. You can see allows you to recover data from a specific point in time down to a fraction of second. You can, that's what I was saying, right? If data, you want data up till 4:30, even though your data got lost at 4:45, you can go back to that particular point of time down to a fraction of second and retrieve that information in that particular aspect, right? And then enable deletion protection. This basically won't let your database get deleted. You will have to go ahead and edit and then disable this. Only then deletion protection. Only then you will be able to delete your database. So I'm just going to leave it here because I want to show you what exactly is deletion protection. It's very useful in terms that you don't directly delete the database. There is no way you can accidentally delete it. The delete option itself won't be available until and unless you you disable deletion protection, right? Then there is other options. Maintenance updates occur any day of the week, but again, you can select one particular day. Let's say on Sunday your application doesn't get a lot of uptime, especially at Sunday at 3:30 a.m. to 4:30 a.m. You can select that over here. Any other update anytime, it's fine. Other options also are available, start date to end date. Yeah, so these are again more specific information about maintenance. I don't need a flag right now. Query insights are disabled. So as I was telling you, 7 days telemetry at no additional cost. This is for free. That is, query insights are basically, as I was explaining you right before, where does the query come from? If the query came from US, what kind of a query it was. If it came from, let's say, Germany, so where did it come from? What did they ask for? You can look into the queries. You can diagnose performance. You can tune the performance according to the incoming queries. Right. Labels are basically giving your database another name which is easier to organize. For example, in this case, I have just the one database, but for an organization, there would be 200 databases. And in that 200 databases, 20 databases will be used for a particular application. 80 databases can be used for another application. So now you can label all of these 20 databases together as one. For example, you can give it a name as test environment, and all of these 20 databases can be within that particular label. So when you search for a test label in Cloud SQL, it'll show all the database information within test. Next, there is let's say 80 databases. In the 80 databases, you can also have another one. You can have a development or the application's name, and that will label all of these databases together. Now, so labeling is done. So these are all the information to create a SQL database. Now let me create it. Yeah, you can see over here, it's getting created, and then it'll take you to a separate page where it shows all the information about your database. You can see the connection name. Eventually, once the database gets created, it'll also give you a public IP address. And then once it all gets created, then I will start and show you how to connect to it. And now guys, you can see that it has been created over here. You can see this particular section from creating, it went to created. And now here from a circular option, it has become a tick, which showing that it's runnable. And now over here, there was only a connection name, right? As I told you, a public IP address has been added. So this is the only IP address which will stay with this particular database until the end, that is until you delete this particular database. The configuration is shown here: 2 virtual CPUs, 3.75 gigabytes of memory, SSD storage of 100 GB. Now, if you want more virtual CPUs and more memory and more SSD storage, you can add it by editing the configuration. You can enable high availability. So when you enable high availability, it'll increase the number of zones. It'll create more replicas. Service account, operations and logs. This will have all the operations which has happened. Over here you can see create is finished, backup is finished. Replicas, we don't have any replicas, ignore that for now. Okay, so now this is where you can monitor your database. As I told you, there is a logging option available. This is the logging option. Second, there is a monitoring agent also running within the database server itself. So that provides you all the data about the database. For example, there is CPU utilization, total memory used, active connections. If there are 10 connections at the same time, it will show you. Right now, there are 0 active connections. Once we connect to the database, then it will show 1 or 2 or 3 according to the number of times we connect. And then how many queries have been run, how much data went out, went in, how many reads and writes happened. Yeah, so all of these can be checked in the monitoring dashboard. Now you can see it for 1 hour, 1 day, 6 hours. So now when I clicked on 1 hour, you can clearly see CPU is being utilized. Because for the server to run itself, there needs to be a little bit of CPU usage, and that's what this 4.23% is, because I've not even opened the database yet. Now I'll just explain these other things in the side very quickly. Coming to users. Now, the username is root. You can create another user account. Never share your root details to another user of the database. So this root account is, again, I created a basic password for this root account. That is the admin123. But when you're actually creating one, give a really strong password. Next, if you want to create a user account, you can just provide a user account over here. I'm just going to provide Cody, and if you can provide a password, you can restrict host by IP address. If you know that all of your employees will be connected to one particular network and will have a similar IP, you can provide an IP address over here, and only connection requests from that particular IP address will be allowed to connect to your database. This is even more secure than just allowing any host to connect. You can provide a password over here, or you can ask them to create one by themselves. And then there's one more option of Cloud IAM. You can create a principal that is basically like a permission. This particular principal gives you a permission to access this database. It creates a set of rules for you to follow. So in this case, I'm not going to create a user account. I'm just going to use the root account. Right. Now, if you want user accounts, you can create over here. You can create multiple user accounts. Connections, right now we have not connected any, but it gives you all the connection options over here. Public IP, if you again want to assign a private IP to it, you can assign one. Security options, currently allow only SSL connections. SSL in the sense you can only log in through a secure shell. You can't directly connect to it using your root credentials. So this is for when you don't have to log into your database, it's already set up. In that case, you just need SSL connections. You don't have to directly log into your database. Connectivity tests, this can be done. This is a one-time process. Let's check. Create connectivity test, test name, test one, protocol, let it be TCP, current cloud instance, destination. I'm just going to provide it as 0.0.0. My first project, I can confirm that the destination endpoint resides in the range of RCV. You can select this or you can just leave it. Doesn't matter. Now it has to show that connection is possible. It is able to reach. Yeah, so you can see here it is reachable. That basically means our database is successfully running. This is just a quick test to check if one particular protocol is working. We are able to retrieve it through TCP. Now you can create another test and check it with, let's say, UDP or SCTP or IPIP. Right. Again, you can select a different protocol and create a test for that as well. So test is done, it's reachable, our database is running. Let me delete this quickly. Now, query insights, I've already explained everything about it. Now, if you want to enable it, you can enable it right here. But again, it's not required for a basic test database. Finally, coming to the connection part. That was the second part of our demo, right? So now, to connect it, you can use the Cloud Shell. The Cloud Shell option is over here. So this is the notification icon where so you can see creating connectivity test, deleting connectivity test. Right. So now to connect, you will have to click on activate Cloud Shell. Once you activate it, it'll take a few minutes to provision the Cloud Shell mission, because even though the Cloud Shell is like this, it is still running somewhere. So this is basically how to say, it's a simple virtual machine running over here. Let me increase the font size so that you guys are also able to read it, and let me move this a little up. Okay, so now I've changed the font size. Let's start off with connecting to the database itself. So to connect to the database, there is an option. So you will have to use the G Cloud itself. So the G Cloud shell, then you'll have to provide the name of the instance, and then once you provide the name of the instance, you'll have to provide the username. I already have it over here. You can see G Cloud SQL. Because for example, let's say you're using MySQL in your local system, then you'll have to connect it like MySQL hyphen h for the host name, hyphen u for the username, hyphen capital P for the port number, small p for password. It will prompt and you will provide the password. In this case, gcloud has its own syntax, that is gcloud SQL connect the instance name, the username. Once you provide that, it will prompt for a password. Then you provide the password, and then it will start working properly. Now I hit enter, authorize it. It's authorized. It will take again a little bit of time to allow list this particular IP to connect to the database. And once it allow lists my particular IP address, and then it will basically prompt for the password. Once it prompts for the password, I enter my password, and that's all basically will be connected to the database. Then we can start executing all our SQL commands. So let's wait until this allow lists. So now it has allow listed. You can see over here connecting to database with SQL user root. If it is any other username, it will show that username over here, and then enter password. So my password is admin123. That's what I've given. Whatever password you entered, enter it over here. Admin123. Sorry, I've provided the wrong password. I will enter it again. So it again allow listed. I'm just gonna enter my password, admin123, and there we go. We are now logged into the cloud database, which is running in GCP's data center. So now to quickly check that, let me show this. Show databases. You can see all the databases over here, right? Let me also show one thing to you guys. Over here, there is an option called databases. Now, let me create a database here and then run the same command over there to check if it's the same database, right? I'm going to create a db1, create this database is created now. It's runnable, database is created. Now let's go back here. Let's run the same command. And now you can see db1, it's updated. I can also create my own database over here. Create database db2, and it's created. Then use database db2, use db2. Database has been changed. Now we are within the database. Now show tables. It's an empty set because we have not created any table right now. Now let me create a table and also enter information. Let me just take it from Google's own documentation over here. Over here you can see I'm using the database, so I'm just going to use this because we are already using a different database. Let me just quickly explain this. We are creating a table called entries, and it has so the name of the first column is guest name, and varchar of any kind of character up till 255, and content varchar of any kind of character 255, entry ID not null auto increment. This create a third column which will automatically increment itself 1 2 3 like a serial number, and then primary key is entry ID, and then we are inserting two values. Okay, let's just do this first, then we'll come back to inserting values. Again, if you want to learn more about SQL, then go ahead and check out our SQL video in our channel because that will have more information. Here I'm trying to teach about cloud, so don't take a lot of information about SQL from here. I'm just using the ones which are already available. Right, now table is created. Oh, see, entries table is created. Now let me create another table. I'm using the same command. It'll throw me an error. Let it be. Now I can clear this. Just copy this. And then we can basically change the entry's name and then we'll be good to go. I'm going to make it as I've named it as another table. Hit enter, it'll prompt us for another one. Now I can just copy this again and paste it. Now we've created two tables. Now you can see there are two tables created within our database, right? Now there is no data in any of the tables. So select star from entries. It's an empty set. Now let's insert some information. Now two rows have been inserted. Let's run the same command. You can see, let's run another command. Like let's see if the where clause works over here. So select star from entries, where content like sorry for hitting the enter, it's just a continuation of that percentage exclamation. So what it does is it shows whatever ends with the exclamation over here. So let me type it again. Now you can see it shows both of it. Now where entry ID equals 1. Now it just shows me that particular row. So this is again SQL. If you want to learn more about it, you can check out that tutorial. So now we've created the database. We've set it up. We've logged in. We've also created a database within the instance. And then I've showed you how to run some basic SQL commands, how to connect to it. The syntax for connection is basically G-Cloud SQL connect, the name of the database and the username, that is -- user equal to the username. That's basically it. Yeah, so hopefully this is clear. This is the end of this particular module, guys. Let me go back to the slides. Yeah, I hope Cloud SQL is clear. I hope the terminologies, the features, and even the demo is clear. So make sure you try this out. It's pretty simple. Create the database instance, connect it to the Cloud Shell. Again, if you don't want to connect it to the Cloud Shell, you have been given an IP address. Use that IP address to connect it to your code or connect it to your local computer, connect it to another server which you are running using GCE. So there are endless possibilities with the cloud database. So that's basically it, guys. Thank you so much. Meet you in the next session.